Hello, hello, and welcome to the first NYJavaSIG meeting of 2021. We hope you had great holidays and you're keeping yourself safe. Before anything, I want to encourage you to use the chat and interact with us during this presentation. We want to know more about you. So let us know where you're from and let us know if this is your first time attending the NYJavaSIG, and also if you're using Java version Superior 10 or after 10. That's important, right? Another thing, we're gonna have a raffle at the end of the presentation. So Venkat was very kind to offer a 1-year subscription to Agile Developer, a company that he founded. There's a lot of good content there, so I encourage you to use. Our team is gonna put the link here on the chat, that form that you need to fill if you want to participate in the raffle. And please use the chat, ask questions as many as you want. Jean is going to be monitoring the chat and is going to be asking your questions to Venkat. So please ask us questions. We want to make it as more interactive as possible. We want you to participate in the meeting. One last announcement, please follow us here on YouTube, subscribe to our YouTube channel. We recently reached over 1,000 subscribers, so thank you. Let your friend knows about it. Here on Twitter, follow us on Twitter at NYJavaSIG. Twitter is where we are more active. And please let us know if you would like to present to the NYJavaSIG. If you have a topic that you would like to see, so please talk to us, let your friends know about our Twitter as well. So without further ado, I want to introduce Dr. Venkat Subramaniam. He's a Java champion, he's an author, he's a founder of the Agile Developer. He co-founded the Dev.Next software conference. He's also a professor. Most of all, he's an amazing person. Thank you very much, Venkat, for being here tonight. Thank you very much, and the stage is all yours.
Thank you so much, Rodrigo. I want to thank you, Frank, Jean, Barry, everyone else as part of the group. Thank you so much for everyone who has joined. So I want to talk about a topic that I've been excited about for a while, which is type inference. Is it a friend or a foe? And that's what I want to focus on. Best time to ask questions or make comments is anytime you have a question or a comment, please don't hesitate, post them on the chat, and we'll get to those questions or comments right away. So let's get started. Let's talk about type inference. Why should we really care about it? Well, there are two types of programming languages out there, as we know, statically typed languages and dynamic type languages. Now, of course, we can also talk about strong versus weak typing in terms of whether the type is enforced during runtime versus compile time, which is where the static versus dynamic really plays a role. Well, when it comes to statically typed languages, is as it turns out that we often specify what the type of a variable is as we are writing code. But static typing itself is more of a spectrum than a dot in space. So it's kind of odd to say Java is statically typed like Haskell, for example, because they both are statically typed, but very largely different in terms of how statically typed they are. But when it comes to statically typed languages, we could spend all our time and effort specifying what the type is, or we can use type inference. As it turns out, a lot of languages actually use type inference really well already. For example, languages like Haskell and Scala and Kotlin are really good examples of languages that use type inference. More recently, though, as time went on, some languages started introducing type inference, even though they didn't have a whole lot of it to begin with. Languages in that category are languages like C Sharp, C++, and of course, Java is one of those to join the party as well. But to be fair, a lot of developers get anxious about type inference starting in Java 10. But as it turns out, type inference has been in Java for a very long time because Java has been introducing type inference over several years, maybe even a decade, if you will. And they've been doing this quietly and steadily. And of course, we took note of it more recently thanks to type inference of local variables. but we'll get back to that in just a few minutes. Let's talk about where we have been before we notice where we are today. Well, in terms of Java 5, we all have used generics in Java. Well, one of the nice things about Java generics is that we can actually use type inference with generics. And of course, when it comes to type inference with generics, we don't have to waste our time and effort specifying the type information over and over. It does make the code a lot concise and type safe at the same time to a great degree, if you will. But on the other hand, when you're writing a code with generics, for example, you could have written the code like so. You would have said integer, for example, maybe numbers is equal to new arrays dot, let's say in this case, a new array list, if you will. And then you would have said integer. But one of the nice things about this is you can simply say numbers dot add 1, for example, and then you could add a 2. And when you're done with it, you could simply output what's in the numbers. So as you can see in this particular case, the result is 1 and 2, but you didn't have to really spend your time and effort specifying what the type is once you create this. Suppose you were to say hello, that obviously would be incorrect and we'll get a compilation error from the code as you're seeing right there, because we cannot pass a string where an integer is expected. Now, most of us may get through this without much difficulty at all, and we could be programming in Java for years and never have to face the next thing I'm going to show you. But unfortunately, occasionally, we work with an API where a code like this will not work. And we have to give what is called a type hint. And a type hint can be annoying when it comes to generics. So for example, you may have to say occasionally an integer like so and provide a type hint to Java. Notice Java did not complain when I did this. And like I mentioned, most of the time we don't do this, but occasionally we'll be forced to do this, and it'd be really annoying when we have to. And I actually worked on a project where we had to do quite a bit of this, and it can be really, really boring and hard to work with such a code. And thankfully, we don't have to do that too often. Well, we talked about Java 5 generics and how it knows the type nicely. When it comes to Java 7, they made a slight improvement to Java 7, which is the use of the diamond operator, which is kind of nice, isn't it? So you can say, for example, list of integer, if you will, numbers is equal to new array list. And like we said, integer right here. And I want to simply output the numbers collection we just created. And as you would expect, it's an empty collection right now. But on the other hand, we can specify a diamond operator, and the compiler is quite happy with it. Well, it turns out that change actually came in Java 7 compared to Java 5, and the type here is inferred again based on the context of what the type is on the left side. Again, you notice a little bit of a type inference that's already happening. But of course, like I said, there are some limitations to this. One of them was in Java 7, we could not, unfortunately, use an anonymous inner class with a diamond operator. So this code will be an error in Java 7 and Java 8, but starting Java 9, this code is perfectly fine. So anonymous inner classes with diamond operators were not permitted in Java 7, but like I said, that's been removed in Java 9, that restriction that is. But the most prominent place where we saw type inference was in Java 8. So let's take a look at what we saw in Java 8 when it comes to type inference. So let's go ahead and create a list of integer here. Numbers is equal to arrays.asList. Let's say a bunch of values given here. Now I can say in this case, numbers dot, and we can say for each, and we could have said integer element. And then of course we could have specified output that element, and we could have written the code like so. Now this is printing the values 1, 2, and 3, as you can see. But in this particular case, we are working with a collection of integers. Now in the lambda, we said the parameter type is an integer. Let's take a wild guess. If you give me a collection of numbers, a collection of integers, and I put my hand into the collection, I take one element out, what in the world could that element possibly be? A puppy? A kitten? No, of course, it's going to be an integer. That couldn't be anything else. So you know it, I know it, the compiler knows it. So why bother redundantly saying what the type is so you can leave out the type? Well, guess what? Right there is type inference in Java 8. So Java 8 allows for type inference for lambda parameters. Now, as a bonus, if we don't have more than one parameter, if we have exactly one parameter, we can even leave out the parenthesis, and that makes the code really concise, as we can see in here. So obviously, in this case, the type of the parameter E is an integer. Make no mistake though, if I were to say .foo over here, very carefully notice the error. The error message says that E, and it says method foo location variable E of type integer. So the compiler clearly found out that the type of the variable is integer, and that is because the compiler infers the type at compile time, and as a result, whether you took the trouble to specify the type or let it for the compiler to infer it, it automatically does that for you, as you can see in that particular case. Well, that is type inference in Java 8. So lambda parameters use type inference in Java 8. Unfortunately, there are a few limitations to this as well. So what are the limitations we are going to run into? The first limitation in Java 8 was that you cannot use annotations, or you cannot provide any annotation on the lambda parameters if you were to use type inference. So for example, if I were to go back to this code and say integer E like so, and notice that at this point, the compiler is quite happy with this code, not a problem. However, if I take this code, I could even say final over here if I choose to. And that's not a problem also, as you can see in here. Likewise, I can also say not null over here and provide an annotation. Now for this, of course, I'm going to say javax dot constraints, if you will, and we'll bring in the validation. So validation dot constraints, and let's bring in the constraints. And you will notice that in this particular case, the compiler is still happy with it. So as long as I specify the type information for the parameter, I can optionally mark it as final. I can also perform annotation. However, unfortunately, if I were to take this example one more time, but this time I leave out the type information from there. But instead, I would like to put final right there, and notice that does not work. That was a compilation error in Java 8. And likewise, if I were to say not null, the code will not compile either. And that is because you cannot annotate a parameter unless you specify the type information in Java 8. Now, good news, that limitation has been removed in Java 11, but as of Java 8, 9, 10, these limitations exist when it comes to it. Well, that's one.
I actually have a question.
All right.
I've seen this presentation several times, and it's never occurred to me to ask, when would you want to put final or an annotation in a Lambda?
Yeah, that's a really good question. Almost never would I want to put final, honestly. So, but I look at final as a kind of annotation, right? So it's not an annotation with an @ symbol, but in effect, we are annotating a parameter. But on the other hand, these annotations are really useful because you might want to specify some constraint on your parameter. For example, you might be programming in Spring and you may want to specify some annotations in Spring. For example, a validator, if you will, that you want to provide and say, hey, when the parameter comes in, launch this validator automatically for me using dependency injection. And if the parameter is valid, then continue executing it. So annotations can be really useful for bringing in things like validators, if you will.
Thank you.
Sure, absolutely. So in this case, we can see the limitation. Like we talked about, that limitation is gone in Java 11, but nevertheless, we need to keep that in mind in Java 8. But there's one other problem, and I want to spend a minute on this problem because I've actually got an email from developers who run into the problem. And I really sympathize with developers when they run into a problem like this because it is very frustrating. And we often may jump in and say, well, Java is being stupid over here. Well, unfortunately, Java is not being stupid. Java simply doesn't have enough context in those cases, and that's the reason why that error shows up. So let's understand this with a little example. And I really like examples like this because it helps us to think a little bit deeper about problems that we may actually run into. So what do we want to look at in here? Let's say for a minute that we are going to work with a collection of people, if you will. So I'm going to bring in a person, let's say a code, and the create people function contains a bunch of people objects, as we can see in here. But what I want to do in here is to call the create people to begin with, let's say create people, and I want to call the create people, get a stream on it, and once I get a stream, I'm going to say for each, let's say system.out and print line using a method reference in this particular case. But what I want to do before we print the values out is I really want to, let's say, go ahead and sort the values, if you will. Let me get back to what I had there. So for each system.out, let's say, a print line. But like I said, before I print the result, I want to sort the data, let's say. So how do I go about sorting the data before I were to print it? Well, I can use the sorted function. That is very useful. And the sorted function often takes a comparator. Notice the sorting is on Sarah. Without sorting, it's Sarah, Bob, Paula, Paul, and so on. But I'm going to say dot sorted right there. But what am I going to pass to sorted? I'm going to say comparing, and I'm going to go ahead and do a comparator. So let's go ahead and do a static import, if you will. And the static import is going to be using, in this case, a comparator. And I'm going to bring in the comparator and the comparing function on the comparator. Now on the comparator, I'm going to say given a person, I want to say person.getName is what I want to sort based on. So when I run the code, notice Bob is the first one, then the Jacks and the Jill, and then of course Sarah in the very bottom of this collection. Now the sorting happened really nicely, and you may look at this and say, aha, but I could have said person like so and provided the type information as such. But naturally, I did not specify the type information. And instead, what I did here is I used the type inference like you see here. Now, the question is, how did the compiler infer the type? It's really important for us to understand that. So when you look at this line of code, only look at the highlighted part right now. When you look at the highlighted part, you have a person, arrow person, but you could call it whatever you want to call it. As some people often do, you could say P arrow P, not that I recommend doing so, but the compiler doesn't care. But the question is, what's the type of this object that you have here? Well, the object type obviously is person, but how does the compiler know that? Well, the compiler performs a type inference by walking through a logic. It first of all takes that lambda and says, my gosh, I don't even know what this lambda is supposed to be. I need some help, the compiler says. So the compiler walks over to the comparing function. And the comparing function is on the comparator. And as you know, the comparing function simply says, like so, it says a comparator on type P, if you will, is going to be the comparing, and that takes a function T comma R as a parameter. Obviously, the compiler has no clue what that T right there is. So as a result, the compiler says, I need some help. What in the world is this T? And the compiler then says, what am I doing with the comparator? Oh, of course, I'm passing the comparator to sorted. And the compiler says, aha, I have a stream of person dot sorted, and the sorted takes a comparator of person. So based on the context, I know exactly what T is. The T has to be a person. So it performs a type inference by walking an extra mile. So the compiler says, I don't know what person type is. Hey, comparing, can you help me? And comparing says it's a T. And the compiler says, that doesn't help me. What are you doing with the comparing's result? Oh, I'm sending it to sorted. All right. Hey, sorted, what do you want? Oh, I want a comparator of person. Got it. T is actually a person. And that's basically how the compiler inferred the type. Well, okay, where am I going with this? You may be thinking. Let's go a little further and take a look at this now. Let's go back to this and say, hey, this is really cool. But what I really like to do right now is not to just sort these values, if you will. In addition to sorting them, I would like to sort them maybe in the reverse order. So I'm going to say create people dot stream, and I'm going to say over here sorted, and we'll come back to sorted in just a minute. And I'm going to say system dot out, and let's say in this case system dot out. Let's go ahead and print out the values, and let's do a print line on it. But what am I going to sort it based on? Let's do a comparing, and person. Let's take the person object given to us. Let's compare based on the person's name. We'll say get name. But then what we are going to do is say dot reversed to reverse the order of the sorting. So I'm going to take this out and reverse it. After all, that's what I'm going to do. And once I reverse it, what am I going to do after that? Simply print the result of that particular operation. So sorted takes a comparing. I made a mistake here. Let's retype that. So that's going to be the comparing operator. Let me see where there we go. So comparing, and then of course I'm going to do a reversed on it, and then I'm going to print it. So hey, guess what happened to the reversed function? Let me make sure I'm in the right place. So I compare it, I reverse it, and of course after that I'm going to print the reversed order. Notice Sarah is in the top now, Bob is in the bottom at this particular point. Now you say, all right, Venkat, that's all great, but what about type inference? Well, guess what? I'm going to go to this code and I'm going to remove the person type from that code. Now, before I go any further, make sure to notice that in here on line number 20, I was able to use type inference on line 20. But on line 25, a minute ago, I provided the type information for the person. So much like in line 20, I want to use type inference on line 25 as well. Now, when I compile the code, unfortunately, I get an error. What does the error say? It says variable person of type object. Wait a minute. What in the world do you mean? And how rude. You think a person is an object. That is uncivil, isn't it? You may think. I agree completely. But what actually went wrong? Well, the compiler thinks that person is of type object and not a type person. But why? Let's walk through the type inference one more time to understand what went wrong here. Well, the compiler takes this lambda expression much like it did before, and it says, I don't know what this lambda is. Help me out over here. And the compiler says, all right, the comparators type T dot comparing on the other hand is taking a function T comma R, but I don't have a clue what the T is. And the compiler says, all right, let's find out what we are doing with it. Hey, what are you doing with the result of comparing? Well, unlike the line number 20 that you saw up here, in this example, you're taking the result of comparing. You're not passing it to sorted, you're passing it to reversed. So you are saying comparator type T dot reversed. So the compiler says, all right, hang on a second. I don't know what T is, but let me see what I'm doing with the result of comparing. Oh, I'm sending it to reversed. And the compiler says, hey, reversed, can you please help me? What's the type of T? And the compiler is like, how do I know? T is T, go home now. And so the compiler says, sorry, I don't have enough context. I'm going to assume it's an object. Now, you may say, why can't the compiler take the reversed and realize it returns a comparator and then go over to sorted? Well, guess what? The compiler already walked an extra mile. Don't push it. So the compiler cannot just keep going forever trying to find it. It tried to look around and say, hey, I'll look around and see what the context is. But if I cannot find it in a neighbor, I can give up at this point because how long do I go looking for this information? So now you know the rest of the story, why this code did not work. And the reason is there is not enough context in that information. So this also shows something to us very important. The type inference is extremely logical. It's not magic. A compiler goes through evaluation to find what the type is. And if the context doesn't provide that information, the compiler has to give up and report it cannot find at that point. And that's exactly what we saw happening at that point. Now, Java 9 quickly.
2 questions before you go on to Java 9.
Awesome. Please go
One
ahead.
of them is on the previous example. Obviously, if you add the type of person back in, the compiler will be happy again. Will it also be happy if you use a method reference there? Does that give it enough context?
Love it, love it, love it. You are absolutely correct. So if I were to use a method reference, the compiler is very happy right now. Whoever asked it, hats off, really good observation. And the answer is yes. And the reason why it is true in this case is it's a bit of a cheating, if you will. You provided a hint to the compiler already. You told the compiler, here is the person class, and I want the method get name of the person class. So when the compiler comes down and looks at the comparing a function, t comma r, the compiler says right away, aha, I know exactly what t is. It's a person. So your observation is really good. So if you use a method reference, you already provide a type hint. But when you don't use a method reference is when the problem is. Awesome, awesome observation. I love it.
And the second question is a spin-off of my at null, not null question from before. What happens if you pass null to something that says that it can only take at not null?
It probably would be an exception, assuming the validator kicks in properly and tells you that.
Okay, we were all caught up on questions.
All right, sounds good. So what about Java 9? We already talked about this. Java 9 allows us to have anonymous inner classes for using the diamond operator. So that's the only change in Java 9. Now, of course, Java 10 brought a slew of features with related to type inference. But like we saw before, I want to really emphasize it. We've been using type inference in Java for a very long time, even before Java 10. So Java 10 is not the first version of Java to introduce type inference. It's the first version of Java to introduce, anger among developers, probably, if you will, but not the first version of Java to introduce type inference. So what does Java 10 actually provide? Java 10 provides local variable type inference. So obvious question is, what does it mean to have a local variable type inference? Well, let's start with a little example to understand this. Suppose we said string greet is equal to hello, and I want to go ahead and output the value of greet. Now, clearly in this example, we specified what the type of that variable is. It is, of course, a string, and the name of the variable is greet. But instead of doing so, we can use a type inference like you see here. Notice the code actually runs just fine and produces the result. So what did we just do? We told Java, hey Java, please infer the type of greet. That's what you are saying. So what does type inference really provide for us? Type inference is a request to Java at compile time to infer the type of the variable based on the context and the initialization information that we provide. Now, I want to mention a few things before we go any further with this. The first thing I want to emphasize, and because sometimes we use words colloquially, which don't mean the correct definition, but that can become misguiding. So I want developers never to say this. Please never use the following, if you will, words. So, and what is that? Var type. There is no such thing called a var type. So I don't want anyone ever to say var type. So what is the type of greet? Greet is not a var type. There is nothing called a var type. So what is greet then? Greet is a string. So in other words, you are telling the compiler, go figure out what the type is. So let me put it in very simple words. You are telling the compiler, hey compiler, you know what the type of greet is. I know what the type of greet is. Do you still want me to say what the type is? And the compiler smiles at you and says, no, my good friend, I know what the type is. You can move on. So, this is a compile time feature. I've heard developers tell me things like, oh my gosh, you put a var right now. Java is becoming like JavaScript. That is really unfounded. Java will never become that evil ever. So we would never want to say something like that. JavaScript is a dynamically typed language. Java is a statically typed language. This information is analyzed at compile time, not at runtime. So what is var really? Let me emphasize what var is. Var is a wink at the compiler. That's what it really is. A var is a wink at the compiler. You literally look at the compiler and you say, hey compiler, I know what the type of greet is. You know what the type of greet is. Do you still want me to say what it is? And you smile and wink. And the compiler says, no, we are fine. I know what the type is. Now, in other words, what we really need to understand here is the following. Notice, first of all, if I use the type information like we normally do, if I go back to this code and call foo, notice what the error message is. It tells you method foo, location, variable greet of type string. Well, clearly the compiler knows the type of greet is string. Well, of course, because we told it what the type is. If I change it to a var, now notice what the compilation error is. It's exactly the same error. The compiler says method foo, location, variable greet of type string. So the compiler knows the type of the variable is string. Let's get back to something even more fundamental about this. If I were to go back to this code and define the variable string greet, now I go to the command prompt and I'm going to say Java P. And I have a Java P aliased on my machine with the -c option already. But if you're trying this on your own machine, make sure to put a -c option after Java P. So Java P, temp classes, sample.class, and I'm going to take a look at the bytecode that got generated. And notice right there in the bytecode, what do you notice? Well, in the bytecode, I want you to notice line number 11. It says string hello. I'm going to leave this on the screen, if you will, and I'm going to go back to the command prompt right there. But I'm going to go back to the code and I'm going to change this to, in this case, a var like so. Now that I recompiled the code and I printed the result of hello, but I go back to the command prompt one more time, and I'm going to fire up the same Java P one more time. Now, notice what it says on line number 11. It says string hello. If you're wondering, that is really the old output right there with the line highlighted. That's the new line output, as you can see. So both of them are exactly the same, except for my highlighting on that one line. So if I move the highlighting down and I'm switching between the files, notice the files are exactly the same, no difference whatsoever. And just to clearly emphasize this and make sure that we really see that, if I go back to this code and put a hello with the exclamation and execute the code, and now with the var in place, I go back and look at Java P one more time and notice that the variable is still a string. The value is a hello with exclamation, but it says the type is a string. So what do we learn from that little exercise? Well, the first thing we learned is that var is being analyzed at compile time. There is no difference whatsoever at runtime whether you put a string or whether you put a var. There is zero difference at runtime. There is no overhead at all whatsoever at runtime, because this is completely determined at compile time. Secondly, the type of this variable is going to be the type that you intend to be in the bytecode. In this case, the bytecode says string because that's the intended type of that variable. Most of the time, the type is what you initialize it to be. Occasionally, it could be even better. And I'll come to the better part later on and show how that actually is. So in this case, we can see a local variable type inference. Now, of course, the one thing you need to keep in mind is the word context. Java requires the context thoroughly, unambiguously, if you will. So as a result, if you take the string, in this case, and if you execute the code, you can see that works fine, not a problem. On the other hand, if you were to define the greet as a variable, and in the next line, if you say greet equal to hello, notice the compiler was not unhappy about it too. However, if you go back to this code, if you said greet is equal to hello, like we did before, and in this case, I'm going to make it a var instead of a string, the context is clear, so the compiler has no problem with it. However, if I go back to this code and put a semicolon and say greet equal to hello, this is an error. Actually, the error is actually on this line. You cannot do that. And what is the reason for the error? The reason for the error is, looking at that line, Java doesn't have the context to determine the type of that variable. In other words, the variable has to know what the value is and infer the value from the context. Now, as long as it knows from the context, it's fine. For example, if you had a function called get something over here, and notice you said a var get something, whereas you said public, let's say, in this case, string, get something as a function name. And I'm going to simply say return hi over here. That's perfectly fine, because the context is enough to determine what the type is, because the compiler goes to get something and says, hey, what are you returning? Oh, you're returning a string. Thanks. I'm going to know that the type of greet is a string. So in other words, the context has to be determined on the line of the definition. That is a requirement. So
got two more questions in the chat.
Please.
One of them was sort of an observation that var is like winking at the compiler to infer the type. So first of all, is that correct?
Var is a wink at the compiler to infer the type. That's correct.
Okay. And is that the same thing for lambda when you don't know the type there?
Well, if you put a var in front of a parameter to a lambda.
No, if you don't put a var, if you just say like E. Is it like you had a var there?
You're always winking at the compiler, because you're telling the compiler, I know clearly what the type is. You know what the type is. I'm not going to waste my time doing it, and you wink at it. So absolutely, if the type you think it is not the same as what the compiler thinks it is, you'll get an error in the case of lambda as much as in the case of using here. The only difference is in the case of a lambda expression, you're not initializing a variable. It's a parameter. So the type is inferred. So context is always there. So in the case of a local variable, the context comes on the right side. So what you're initializing it to. In the case of a lambda expression, the context comes from the functional interface and the function that is part of the abstract function that's part of the functional interface. So where the context comes from is different, but the winking is still the same. In one case, you wink at it to say, go get the context from the definition. In the other case, you wink at it and say, go get the context from the declaration in the functional interface.
Okay, and the last question in this set of questions is the reason to use to not mention a type in a lambda for readability or for something else?
Yeah, so that's a really good question. Why do I not want to specify the type? I'm going to expand on that in the next several minutes. And if I don't answer that clearly, I encourage that question to be asked again or rephrased. But I'm going to give several reasons for it in the next few minutes. So I'll get to that in just about a minute or so. So the very first thing is use type inference only when the type is 100% clear, both to the compiler and to the programmer. So the obvious question is, why bother with this? What are we achieving by doing this? Now, in this example, if you will, if I were to say string over here and greet, and versus if I were to simply replace this, if you will, with simply a var instead of a greet, what am I going to achieve by actually doing so? Well, not a whole lot, you may argue, and I will have to agree with it, because all you're doing in here is you're saving 3 characters, if you will. So the saving is rather minimum in this particular case. However, imagine what you have is something like a map of, let's say, a string, a comma, a map of, let's say, an integer, a comma, a list of string. Sometimes we deal with data types from hell, and then you say my variable of some sort is equal to, maybe this is going to be, some scores or whatever that's based on the domain. Now, when you're dealing with something like this is rather verbose, if you will. And how many times have we dealt with this where you have all these angle brackets and you're not sure exactly how many it is placed, and you go home at the end of the long day and the family looks at you and says, what's all this bruise on your hand, on your arm? And you say, oh, I've been working with angle brackets all day. That's what it caused it. Well, in this case, you can simply say var my domain specific variable name, obviously not long name like that, but put a name that is specific to the domain to say what it is for. For example, var, scores, for person, or for scores for player, or something like that. Well, in the domain context, we know what that is, so you can avoid the verbosity. Now, here is one of the things that is important for us to really get comfortable with. Now, I come from a background of programming. So a long time ago, I programmed in one language. And I thought I knew everything when I programmed in one language. Then over the years, I realized that I really need to diversify my knowledge portfolio. Well, today I program in about 15 to 20 languages. Well, that only means that I'm not good in any one of them. But I really like programming in multiple languages. And having programmed in C# and C++ and Scala and Kotlin and JavaScript and Ruby and Python, well, I'm used to not specifying the type, but in statically typed languages like Haskell, for example, and also in Scala and Kotlin, when I don't say the type, the compiler fills in the gap for me. So I'm already used to that particular idea. But if you have a developer who is only used to one language, they will have a different perception on this, and understandably so, that's perfectly fine. But I want you to entertain this thought for just a minute. Think about the neighborhood where you live right now. And let's assume you lived in the neighborhood for, let's say, 2 years already. If you're newer to your neighborhood than 2 years, think of the neighborhood you used to live for more than 2 years. When you first went to that neighborhood, you had no clue where things were. You don't know where the library is. You don't know where the post office is. You had to look up the map. You had to ask for directions. And when you're driving, you look at the street names and you want to know where to turn. And that's pretty normal. But once you lived in that neighborhood for 2 years or so, what do? You just get there. You very rarely look at the street signs. Honestly, in your street, when was the last time you looked at the street sign as you drove by or walked by? I never look at my street signs in my neighborhood unless something interesting is happening on the street sign. Maybe a beautiful bird is sitting on it. But the point is, to me, the variable types often are like the street signs. They are useful when I'm new, but they are noisy and redundant once I'm used to it. Well, a lot of us spend hours on end on our code bases. And oftentimes we don't need as much information about the type as we think we do when we are used to the code base. When we are new, we will need it. But here's the challenge I want you to think about. What if you have a nice little IDE, and most IDEs do this, and you hover your mouse over the variable name, and they immediately show you the type information for the variable? Well, my goodness, now all of a sudden, your code is not noisy, but you can find the type if you need it by hovering over it. So you get the best of both worlds. The code is less noisy. You don't have to endure the pain of all the type information. You don't have to type all the type information. And even if your IDE was capable, you right click on the IDE and then it vomits the type information. That's a noise in the code you have to see. Your eyes spend time parsing all that information over and over and over. We don't often think about it, but that's a fatigue that we develop when we look at the noisy code. Whereas when you give a context of a name, domain-specific name for a variable, the type information becomes redundant most of the time or less important. And once you get used to it, it's really hard to go back to it as it has been for me. However, the worst way to introduce a concept to a team is to force them to accept it. So I often never go back and tell my team, you have to use bar. If the team is not comfortable, don't force them. Just continue to say what the type is. There's nothing wrong with it. But when you're writing the unit test, for example, remember how our unit tests are supposed to be really, really small, 2 or 3 or 4 lines of code. In the unit test, I call a function get a parameter. Well, put a var in the unit test. My developers will come to me and say, hey, what's that var doing there? Oh, it's just a unit test. It's a silly 4 lines of code. You can see what the type is. We don't need to really waste our effort putting the type information. And they're like, fine, we'll leave it there in the unit test. And about 4 or 5 months goes by and a developer says, gosh, we have been using var in the unit test. This particular local variable, why can't we use it? You say, what a great idea. And you start having them use it. So it's really important to take the time to get comfortable. And again, I want to emphasize, if you're very used to type information, it is very logical and natural for us to become apprehensive. And it's okay to get apprehensive. There's nothing wrong with it. That is us as human. And then reason with yourself and say, how is this helping me? Do I want to keep it here? Or am I better off not using it? Can I get comfortable with this idea over time and see if that actually helps? And anytime it's not helpful, fall back on putting the type. There is absolutely nothing wrong in doing so. So we talked about the local variable, and this is only available for local variables. So you can specify the var for a local variable like greet, as we can see right there. But like so, we could also do the following. We could have said, for example, list of string names, let's say, is equal to, and what do I want to do with the names? Well, I could say something like a list of, or maybe we can bring in some names over here. So we have names like Dory and Gil and Bruce and so on. And what I could do in here then is I could specify in this particular variable, maybe I could say, hey, rather than the names like so, I can say for a string name coming from names, and I could output the value, maybe name like so right there. Well, that's great so far, but I can also do one more thing. I can go back to this local variable and I could say a var right there and say names, and that's perfectly fine because it's a list of names I brought in. Likewise, I can say a var for the for as well, and I can use it right there, and that's perfectly fine too. So I can use a var name of names. What in the world is the type of name? Well, it's an element from names, obviously. So I know exactly what the type is. I don't need to specify the type. You can wink at the compiler. Similarly, you could also use this in a try, as in using a try with the auto closable. So for example, if you had a implements, if you will, you know what, let's actually try something a little different. What if I had said something along the lines of IO dot star, and I'm going to say over here something like a try a file reader. Let's say reader is equal to new file reader. And let's go ahead and say, you know, some file, let's say sample.java right there. And I'm going to use the file reader. And maybe within here, I'm going to do something with the file reader. Not, just print it out, but whatever I want to do. Well, most likely I will have to deal with the exception at this point, but we can do that. So it says file not found exception must be caught. But as Java programmers, we know exactly how to take care of that. So we'll simply say throws exception right now. And you can see the code is working as we expect it to work. However, you come back to this code and say, did I really benefit by saying file reader over there? Or can I simply use a var because that's purely a noise in that context? I gained nothing by saying file reader right there. So I could simply use a var in the try as well. Well, those are the places where you could use it, but you cannot use it for a field, however. And if you ask me why, my answer is not yet. So there's no reason, in my opinion, why we cannot use type inference for fields. So for example, if you had a private int max equal to 1,000, if you will, well, in language like Scala and Kotlin, you could use a type inference for that. But whereas in Java today, you cannot use type inference. So this will not work, as you can see. But the reason is why? Only because they have not supported it yet. I really think that one day they may support it. Once the displeasure of type inference dies away and it becomes more accepted, I think they may eventually do that, but not yet. However, you cannot use type inference for parameters. So for example, if you had a function like, some, method, and in the sum method, I had a string, let's say message like so. And in this particular function, as you can see, that's perfectly fine. But if I were to change it to a var over here, that will not work. And I hope it never works. And I say that because there are few languages that actually infer the type of parameters. And some of those languages are languages like Haskell and F#. Both Haskell and F# can infer the type of parameters. You see, Kotlin and Scala were influenced by Haskell. But the developers behind the Kotlin language and the Scala language decided not to use type inference for parameters, and I absolutely agree with that decision. And the reason I say that is, to me, a method signature is sacred. And I don't want the implementation of a method to change its signature. And as much as I love and respect Haskell and F sharp, that's one feature I don't like in those languages. I don't want type inference on parameters, and thankfully Java doesn't provide inference on parameters either. Well, we talked about some really the basics of type inference and how they actually work and where we can use them. But I want to step out back and talk about some caveats, some do's and don'ts, and why we should be really careful. But I'm going to just pause for a minute and see if there are any questions or comments before we start diving into some do's and don'ts. So
Yes,
I'll yield to
we
you.
actually have two.
Oh, go for it, please.
We have a little bit of an IntelliJ posse in the chat who have pointed out that IntelliJ can fill in the types and names for you. So why ever would you need to think about them?
IDE vomit. If you're okay to live with the vomit, I have no problem with it.
All right. Hopefully we won't be back for the next round of IDE wars. And the other one was an observation that people read the code many more times than it's written, so you want to make sure it's readable. Can you give a little thing about when var is readable and when it's not, or is that something that's coming in the caveat section?
It's always readable, in my opinion, as long as the context reveals it for you, right? So again, this is why I was talking about the road signs. To me, a noisy code is not readable. When a code conveys the information it needs to convey, anything more you provide is taking my valuable time away from it. So if you were to say in here, a string name, and if you were to say here, file reader, this is 99% of the time, I'm glossing over that. Because, you know, one of the things people don't think about, and I'd say this with utmost respect, right? We are programmers, but we take ideas and we forget the context of applying the ideas. When people talk about reading the code, you don't read the code line by line, character by character. You are reading the code in a very different way than sequentially trying to read every line of code. When I read the code, I am a person who is very impatient, as a lot of people are. I am interested in asking, what does this code do? Don't tell me all the details. Give me the big picture. Then give me a little bit of a more refined picture. And I want to be drawn into the detail than the detail being poured on me in the beginning. So when we read the code, we often glance at the code, we get a feel for the structure. We get a feel for what are the major things happening in the code. Then we get a feel for more finer grained details. So when I read a piece of code, the more information that is there that is not important for me to get the bigger picture is a disservice for me. And that is one of the reasons why it's important to understand what readability really means in the context of code. If you have developers who are saying R and who are using the word N, this is a crime, in my opinion, that should be punishable under law. And maybe it will be when the law changes eventually. Because to me, this is an example of a code that's totally unreadable. You know, how many times I look at a piece of code and I see a variable called X, and I'm like, oh my goodness, what does X even mean? And this is one of the reasons why I get angry when programmers write lambda expressions where they say names dot, and then they say stream, and then they do a dot map, and then say X arrow. And I curl up in a ball and cry oftentimes because I have no clue what X means. To make things worse, you could even say string X, and that is only adding insult to injury because I don't know what X means. And now I know that it's a string, which is totally useless to me most of the time. But instead, if you say, for example, name arrow, well, now you've told me you're mapping the name to something. And the word name means something specific to me in the domain, in the context, right? So it's kind of like when you're at home, you don't say this is dog one and that is dog two. No, we give nice names to our pets and we say, oh, here is, you mentioned the name of the pet. Hey, here is Buddy, and Buddy is extremely friendly. And then you say, here is Rover, and Rover is, mostly friendly, except when you're playing with Buddy. Well, we use logical names. You don't keep using the word, here is dog Buddy, and here is dog Rover, right? That's not the way we communicate with people. So the point really is, when it comes to readability of code, we really need to understand what readability actually means, and don't confuse verbosity to readability. So readability comes from context, not from verbosity. And you can absolutely beg to differ, but that's been my experience having read code from arbitrary clients and companies I work with. It is the code like this, where there's a variable called R, and repeatedly I see a R over the code, and I get angry and scream and complain oftentimes, because to me, context really matters. The type is given once, and I can fill in the type any number of times, but the variable names are more sacred for me, because that's an abstraction that needs to be carried through. And that is what we need to really be careful about. So in all honesty, I say this, I don't care whether you say string or a var. I'll be the most unhappiest person in the world if that is followed with the X. It doesn't matter to me whether you put a var or a string. I don't want to see an X over there. So to me, the context always matters. And that's what is really important. And once the context is given properly, we can always figure out what the type is, because most of the time that leads us to the information we need, not unfortunately X or Y or Z.
One more question on this screen. In the try with resources example, before you changed it, it said the word reader 3 times on that line. So clearly file reader didn't add a lot of value, because if you don't know it's a reader already, and it's quite there. With string names, you have to look a little further up to see that the names are strings. How far away are you willing to look in order to determine that context?
Not at all. When I work with a piece of code, if you, let's say you put a string names, what is names? Do you know what names is in your context? If you don't know what names is, how long have you been working with your source code, right? So again, I want to emphasize domain specific names. Okay. So if this is employees, for example, well, what in the world is employees with the plural? Well, it's a list of employee. Gosh, okay, I know what an employee is, because an employee is absolutely going to be, an employee is going to be a type of employee. So if you are not able to find what this variable name is based on the context, you can try to fix it by putting a type here. I would rather fix it by putting the context over here. That's why I cannot emphasize this enough. If you're working in a team where people are giving ridiculous cryptic variable names, I really am sorry. You will never get my sympathy for that, because I want contextual names for variables. And when the names are contextual, type goes into the shadow. When the names are cryptic, the types become the crutches. And that's what you notice. What you're noticing is not a requirement or an essential part. You're looking at a solution to a symptom. It's a medicine. It's not a prevention. That's the key to keep in mind.
And the last question before we're all caught up is, you talked earlier about hopefully or maybe instance variable type inference is coming. Do you have any thoughts on why that wasn't there? Maybe?
No. So I'm not saying it's coming. I'm saying I hope Java will eventually provide type inference for fields.
Got it. And do you have any thoughts on why they didn't originally? Like, was it harder? Was it a backward compatibility issue? Mystery?
It's a completely different area for a compiler to work on, right? It's not a related feature. This is one of the caveats. I fall into this trap all the time myself. As a programmer, it's very easy for me to take two things and think they are one, but at the compiler level, they're extremely different. The effort to infer a type of a variable in a local variable situation requires a very different coding than inferring variables at the field level. So it's prioritization, number one. Availability of resources is the second one. And third is adoption. Right here we are seeing so many people throwing doubt on why we should use type inference. When language is supported from day one, we often don't question it. When it is being introduced in a language, it's a huge effort because we don't want such change. This is different from what I know. I want you to put the type back again here. Well, when that is kind of the nature of the change, why would you want to do more of it until this becomes the norm? People begin to accept it. People begin to use it. And then you say, gosh, now that you're using this so often, let's also do this on field. The adoption becomes a lot easier. So there's a very big difference between a language which is new and it introduces a few set of features to a language which is existing, and they want to introduce a feature that is bound to be controversial as it is. As you can see, they have to be very gradual in introducing. So resources, prioritization, and gradual adoption would be the reasons I would specify.
Cool. And we are now caught up on questions.
All right, sounds good. Thank you again for all those questions. Keep them coming. That's absolutely wonderful. And that's what we want to be doing, is to make it as interactive as we can. So I really appreciate that. All right, so some do's and don'ts. And I want to really be clear about it. I am not here to tell you type inference should be used. Is it a friend or is it a foe? That's the question. And I'm going to say it's neither. It's not your friend. It's not your foe. It's just a tool. Frank posted a beautiful picture of a grasshopper and the all those insects, and you can look at them and say, is it a friend or a foe? I love that picture he has drawn. I absolutely phenomenal. But to me, it's neither. It is a tool. That's what it is. And I don't have love and affection to my screwdriver. Honestly, screwdriver is a tool. I use it where it makes sense. Where it doesn't make sense, I don't use it. That's what var is for me. So don't use var with the diamond operator. This is foolish to even try, in my opinion. So list of integer, and in this case, numbers is equal to new array list of diamond operator, numbers dot add 1. And of course, I'm going to simply say OK right here. And the compiler is fine with it, as you can see, not a problem. However, if I go back here and say hello, that code will not compile, obviously, because it's a numbers is a list of integer. You cannot put a string onto it. However, this is a bad idea. So if you change this to a var like so, and I'm going to quickly put, please don't do this. This is a bad idea. Why? Why not do this? The reason we don't want to do this is, if you go back to this code now, and if you were to call add with the string, notice the compiler doesn't give you an error. Why is that? Honestly, I would have been happier if they gave an error on this one. But the numbers is inferred based on the context. Unfortunately, the context here says it's an array list of angle bracket. So that becomes a list of object, which is probably not what we wanted. So this is a terrible idea. Don't use var in this situation. In fact, I'm hoping eventually tools will become smart enough, if not the compiler, to tell us don't do this. Secondly, this is not a problem of type inference. I want to emphasize it, but unfortunately, this problem comes to light too easily with type inference. And some of you may know this, for others it may be a surprise, but let's take a note. Suppose you said list of integer numbers is equal to, let's say, new array list of, let's say, integer, and we'll say 1, 2, and 3 as the values to specify right there. So I created an array list of numbers, as you can see. And in this case, I'm going to simply say arrays dot as list of 1, 2, and 3. So let's put a bunch of values together on this array list. So now I'm going to output right there. What do I want to output? Well, in this case, I want to output the numbers in this particular collection. So the result is a 1, 2, and a 3, as you can see. Well, this is unfortunately a problem in Java 5. I really wish they had not done this. So if I say numbers dot remove 1, and I want to print out what the numbers are after I remove that particular number. Notice the result is 1 and a 3. I want you to keep that in mind. The result is a 1, 3 as the response you got from this collection. Now, unfortunately, there's a mistake they did, in my opinion, in Java 5. And that is, if you take this line of code and in here, if you replace this list with a collection, unfortunately, notice what the output is. It's not a 1, 3 anymore. The output is a 2, 3. The reason why this is a mess up is they unfortunately overrode the remove function differently between collection and a list. Like, I want to emphasize this. This is a problem from Java 5, not a problem of type inference, except that problem exasperates when it comes to type inference. So if you had this code, let's say, and you look at the output is 2 and 3 right now, as you can see. Now, if you are in an environment where you have a fairly decent amount of unit tests, this may not be a problem. But if you don't have as many unit tests, or that particular code is not covered as much, now we are in trouble, if you will. Notice the output at this moment is a 2, 3. Now, if I were to replace the collection with instead of var, if you will. So now in this case, notice the output is unfortunately a 1 and a 3, not a 2 and a 3. The reason is, a minute ago, this variable type was collection, but now numbers is actually an array list. And that's probably not what you expected, but that's what it does. In other words, it always infers the type based on the context information. In fact, I would argue this actually defeats one of the recommendations from effective Java, which is they say interface variable is equal to new class name, right? So, but when you use a var, what happens? If you put a var, unfortunately, this becomes a class name variable. So you got to be really careful in a situation like this. It goes from a variable of type interface to a variable of type class name. Do you really want it to be that is a question you need to ask. And that's a decision you have to make very thoroughly when you start using type inference. This again goes to the base versus derived, and we got to be careful about it. Well, you cannot use type inference to store lambda variables. So what do I mean by you cannot use it to store lambda variables? Well, let me explain what that means. If I were to say runnable, let's say runnable is equal to, and in this case, I'm going to say just a lambda right there, output, let's say hello. And I'm going to say runnable.run and call it. So in this example, we defined a lambda called runnable and we execute it. Now, if I get really anxious about it, and if I were to say var, that is an error. You cannot do that. Why not? Because lambdas don't have type information until they are bounded to a functional interface. So again, context matters. So because there is no context, the compiler cannot determine what the type is. So you cannot use them to store lambdas. When I say you cannot, seriously don't. Because some developers may really say, oh, really? Let me show you how. And they may say over here something along the lines of runnable, and they may wrap this whole thing into a runnable like so. This is a terrible idea. There is zero reasons to do it. So I'm going to say, please don't. This makes zero sense whatsoever. These people are eager to use a var for a wrong reason. Never allow people to do this. This is verbose and defeats the whole purpose of using var in the first place. So don't do this in the case of lambdas. Lambdas cannot be and shouldn't be assigned using type inference. So, but having said that, there are some benefits to this, if you will. First is it can reduce clutter in the code. So if your type information is redundant and can be really found out by using IDE support, by good context of variables, familiarity with code, why bother to do it? The code is easier to evolve because, why are people excited about languages like Python? Well, languages like Python make it easier to experiment with the code. When I'm trying to put the code together, the compiler says, what's the type of this? What's the type of that? And you're like, really, compiler? I'm just trying to make some code to work. Can you please step away? Let me try to experiment with this. It's like, fine, go ahead and do it. So it's easier to evolve the code and experiment. Easier to reuse as well. Let's see how with an example. Let's say for a minute that I'm going to bring in the create people example we saw a minute ago. So I'm going to bring in a create people. Let me try this again. Where did that go? So I want to bring in the create people file. We'll bring that in just a second and we can look at it. So I want to bring in the create people. Let's see where that is. There you go. So I want to bring in that particular function. And in this case, let's try something a little different. I'm going to bring in the collectors over here. So I bring in the collectors. And in the collectors, I'm going to say something along the lines of create people, let's say dot stream, let's say dot collect. And I'm going to say over here, grouping by, and given a person, I want to take the person's get name. And like you said earlier, I could even use a method reference if I wanted to. And then I may say something along the lines of in here, why not say a comma mapping? And let's go ahead and say a person get age, comma to list. And let's go ahead and say at this point to the compiler, I want to simply say OK to say the compiler is quite happy with that piece of code, if you will. So in this case, we call the get name function on the grouping by, let's say grouping by person, and then I want to map it and mapping based on the to list of this particular object. And then finally, of course, I want to go ahead and get that value. Now, in this particular case, let's say you are interested in reusing this particular function. Maybe down below, you have a create people too that you want to use this in. So let's entertain the thought for a minute. So just pretend that this is create people to another collection. Now notice in this case, we had to duplicate the grouping by function. And you tell me, all right, Venkat, let's not duplicate it. Let's reuse it. So how am I going to reuse it? I'm going to say group. Let's say grouping by name and map to age, or whatever variable that you decide to create over there. Well, the variable name is called grouping by name and map to age. And so I'm going to go ahead and say grouping by name and map to age is equal to, and what is that value going to be? Oh, that value is going to be this particular function that I have created right there. And now I'm asking the question, what in the world is that variable? Oh, your answer is very easy. Right click on that variable or press the command Control V. And before you could imagine, the IDE vomits that variable type for you. But the question to me is, do I care? And do I really care what the type of that variable is? And if you say you really care about it, go for it. Specify what the name is, absolutely not a problem. But if you don't care what the type really is, then you don't have to waste your time and your effort to specify all the type information over there, because you can simply tell the compiler, go figure it out. I don't need to tell you what the type is. In fact, here's the fun part. If you are kind of curious what the type really is, go over here and you can find this from your IDE. But if you really are curious, you can find out what the type is. And watch very carefully what the type is. The type is collector, angle, person, comma, question mark. Even the compiler doesn't care anymore. So why should I? So the point really is, we can really do away saying, I don't care about the type right now. That is the least interesting to me. I'm abstracting the idea in my mind. I'm working logically with this code. That level of detail is to no benefit at all whatsoever. And if I really need it, I can hover over and find it when I need it. So it's easier to reuse as well. It's a lifesaver when it comes to debugging. A lot of times I want to quickly take a look at a particular value I might assign to a local variable. I don't care about the type. You can use this for a targeted intersection type. What in the world does that really mean? Let's take a look at an example of what that actually means in this context. Suppose I were to say list of object. I know. Let's say values equal to, let's say list of 1 comma hello. And in this case, we know that a list of gives us an immutable collection, but that's okay. Let's say values dot add, and I'm going to say a 2 right here, and let's do a catch over here of exception, and we'll simply go ahead and report the exception that we got. So we want to know the compiler is compiling the code just fine at this point. That's what we really want to do. Oh, try without a catch, did I? Yeah, there you go. So right there, I want to know that the compiler is happy. Well, notice the compiler is okay with it, not a problem. In fact, now that we know the compiler is okay with it, we'll simply say okay here, so we can know that the compiler is quite happy with our execution. So I'll simply say okay. Now, this is the code we wrote so far. Here's where the intersection type really comes in. So if I were to go back to this code, and if I remove this and put a var, now here's the charm. What is the type of the values? It turns out the type of the values is not a list of object as we would think. It turns out the type of the values is a lot more. Like what? Easy way to know is to say new sample. Notice the compiler is not happy anymore. But look at the error the compiler gave us. The compiler says the type actually is object, comma, serializable, comma, comparable, angle bracket, comma, constable, const desc. What in the world just happened? Well, the compiler analyzed that line of code, and the compiler, upon analyzing line number 5, determined that what is common between 1 and hello is not that they are just objects. What's common between 1 and hello is both 1 and hello are object, but they're all serializable, they are comparable, they are constable, and so on. So the compiler determined the type thoroughly by analyzing the variable to determine the type, as you can see. Well, the last thing here is that it also is useful for anonymous non-denotable types. What in the world is a non-denotable type? Well, a non-denotable type is a type that the compiler knows about, but it won't tell you what it is. Let me give you a trivial example of that right here. Suppose you said something like, let's say an object, inst is equal to new object. And within this anonymous inner class, you said private, let's say string info equal to hello. So I have that object here, and I want to output the instance right there as an output. Now we know that that type right there is a non-denotable type. Hey, what is that? It's a $1. What does a $1 mean? Well, it's an anonymous inner class. Now you go to the compiler and say, hey, compiler, I want to go to the instance and get the info out of the instance. What does the compiler say? The compiler says, sorry, dude, object doesn't have an info. And now you're like, what do I do? Well, you go to the compiler and say, hey, compiler, is this of a specific type? Compiler says, what is it? It's anonymous inner class. Does it have a name? And the compiler says, oh, yes, it does. What is the name? Compiler says, I won't tell you. And there's a stalemate. You tell the compiler, but you know the type, don't you? And the compiler is like, I do. Well, guess what? It is that. This is a big wink and a tongue in the cheek. Now what happens? The compiler is like, okay, you win. Why? Because you told the compiler, whatever the type is, you know it. I know it, even though you won't tell me what the name is. It is that. And get me the info out of it. And the compiler is like, okay, you win. So as a result, this becomes really useful for a non-denotable type. Well, one other small detail. Don't take this to the head, but var is not a keyword. So if you really want to mess with your colleagues, you do this, but don't ever tell them, I gave you this idea. But you notice that var is not a keyword at all. So if you said a var max equal to 1,000, notice the compiler is quite happy with it. Not a problem. But if you really want to mess with your colleagues, go ahead for it. A var equal to 1,000. Var is not a keyword at all. And that's perfectly fine if you want to do it. Well, no, I don't suggest you do this. But the point is, if you already have a var as a variable in your code, you're quite okay with it. So for example, int var equal to 1,000 is not a problem either, because var is not a keyword. Well, I'm going to wrap up with a couple of small quick note in here before we wrap this up. Quick note on Java 11. Java 11 removed the constraint from Java 8. Let's look at that really quickly in here. So if I were to go to Java X, and let's go ahead and say that I want to bring in the validation dot constraints up here. So what I want to do is to bring in the lambda we looked at. So numbers is equal to list of, let's say in this case, 1, 2, and 3, and numbers dot, and I'm going to say for each, and let's say not null, integer e, and I'm going to output the value that we have so far. Now, in this case, as you can see, that was not a problem. But what if you wanted to put the annotation, but not put the type information? Remember, that could not be done before. It gave us an error, so you couldn't do that. Well, good news, we can do that now by putting a var. So what does a var say here? The var is useful on a lambda parameter when you want to annotate it. So I want to emphasize it. If you don't want to annotate, do not put var. So in other words, please do not do this. So don't write code like so, where this is a bad idea. I don't want to ever see this code. No, don't do this. This is, even though it will compile, it has zero benefit. Why? Because what you really want to do is the above, or you want to just leave out the type entirely. And of course, you could use a method reference, right? But the point really, where it makes sense, but the point is do as in line number 8 or in line number 9, but don't do what's in line number 11. So moral of the story, a var can be used in Java 11 to annotate a parameter when you want to specify annotation, where you're saying, I don't want to say the type, just use a type inference. You cannot mix var and different parameters with the types information or with implicit type, meaning type inference without a var. But those things you will figure out by compilation error. You cannot get away with it. So is this really useful? Yes, if you're using annotation. So in the last about 2 minutes left for us, I want to quickly mention some recommendations. please don't use with the arrow. Use a type when you're going to use an arrow. I'm sorry, not an arrow, but a diamond operator. Don't put a name with the type information. I've seen people do this often. They would say names list or employee list. No, we're clinging on to the type. Rather than putting the type in the left, we're putting the type as part of the name. Get comfortable giving domain-specific names rather than putting the type in there. Make sure the type is what you really expect it to be. It shouldn't be any confusing at all. Specify the type unless it is absolutely obvious. My goal is never to use type inference. My goal is to make the code less verbose and readable at the same time. So don't get infatuated to use var. Type should be clear. If it is not obvious to you, don't use var, specify the type until either you get comfortable with it, or that may not be the situation to use a var in the first place. Don't bother in that case. And then finally, of course, use var for temp and debugging, use it for reusing, and use var to annotate lambda parameters when you want to use it with type inference, as you do in Java 11. So hopefully that gives us an idea about the benefits of type inference, what that is, where we can use it. I'll be absolutely delighted to hang around and chat a little bit more, answer questions, receive your thoughts. Anything you would like to chat about, I'll be delighted to. Thank you for coming again.
Thanks. We're going to take this opportunity to draw the winner, and then we'll see if there are any final questions. Since our prize was being donated by our speaker, would you like to tell them what they've won?
Oh, so absolutely. So I have a site called Agile Learner, and Agile Learner is a video site. I'll just bring that up here. And the Agile Learner site has a number of presentations that I've posted over the time, and developers can go in and view any of these presentations that they are interested in. And the subscription gives them 1 year access to those videos.
Awesome, thank you. As part of the drawing, we asked everybody one question, which is, which of the following type inference features in Java have you used? The choices were var, val, val and var, and def. Most people knew it was var prior to the start of the session. There were a handful of people who picked other items, so hopefully they all learned something during today's session. Today's winner is Vladimir Zakharov. We'll be sending you an email with the code to redeem your prize immediately after this presentation. In the chat, we have a bunch of thank yous, but no new questions. So I'm going to turn things over to Rodrigo for closing remarks.
Thank you.
All right. Thank you, Jean. Just want to announce our next event is going to be it's a hands-on workshop. For those who are new to the NYJavaSIG, we have 2 types of events, the talks, the presentations, like we had today with Venkat. And we also had a hands-on workshop where you have the opportunity to do it by yourself and learn by doing it. So our next one is going to be on January 20, 6:30 p.m. Eastern Time. Our guest is going to be Sven Rupert. I hope I'm pronouncing it closely to the right way. He's from JFrog, and he's going to present DevSecOps from scratch for Java and Kotlin developers. One thing to keep in mind, the number of slots available for the hands-on workshops are limited. So you must follow us on social media to learn when this event is going to take place, when the registration is going to open. So follow us to know firsthand so you can guarantee your spot. Venkat, thank you very much for having you. It's always a pleasure to have you. We always learn a lot from you. Great presentations. Thank you, everyone that attended the event today. I hope you enjoy it. Thank you.